So if you are not in class today, today we will be doing a metals, nonmetals, and metalloids lab. And you are more than welcome to stick around and view the lab from the Chromebook I have in the classroom. If you prefer, I'm going to go ahead and kind of talk you through the lab, and I'll show you some of the substances so you can make some of the observations yourself, and then I'll kind of just talk through some of the results with you as well. So what you first need to do is read this background information in your lab handout. Make sure you thoroughly read over the procedures so you understand each of the tests that we're going to conduct today on these substances to see whether they are a metal, a nonmetal, or a metalloid. So the first step is that we're just going to make our initial predictions about whether we think they're a metal, a nonmetal, or metalloid based on their appearance. So this is what each of the samples looks like, starting at the black substance here that kind of looks like coal, which is coal, is carbon. This would be aluminum at the top in the middle. Copper would be with a Cu on the container. Zinc has Zn on the container down here. Sulfur at the bottom. Then you have silicone here, that is a silvery substance. And then in the middle, you have magnesium. So go ahead and make your observations on whether, or your predictions on whether you think those are a metal, a nonmetal, or metalloid. And you're going to make that prediction right here inside of your data table. The next thing you're going to fill in your data table is whether they have luster or no luster. And luster means whether they are reflecting light and are they shiny like a metal is the standard that we're going to use here. So as we go through these samples, we can see that carbon is here. I would say that carbon does not have luster. It's more like a glass. It does reflect light, but not like a metal. I would say aluminum is a yes. I would say copper is a yes. I would say zinc is a yes. I would say sulfur is a no. I would say silicon is a yes. And I would say magnesium, although it may look a little bit tarnished here, it definitely does have luster. It is reflecting light like a metal would. So I would say yes on magnesium. So where you're going to fill that in is right here in this portion of the data table. So you can go ahead and do that. The next test that the students are going to run on these samples is a conductivity test to see whether they actually allow a current to pass through them and whether they will complete a circuit. So the conductivity test looks like this. You have a battery pack. You have two wires that are now connecting to the sample. If that sample completes the circuit and allows electricity to pass through it, it is a conductor. If it does not, we call it an insulator. So what you're seeing here is actually a sample of zinc, and you can clearly see that zinc is a conductor. What you will have inside of your lab here, and I will kind of go through the samples with you, is that we would say that yes, copper will conduct electricity. For aluminum, aluminum also is a conductor, so you'd put a C here for aluminum. Carbon does not conduct electricity, so we would put a I for being an insulator. Silicone does not conduct electricity very well, so we would put an I here. Sulfur also does not conduct electricity. We put an I here. Magnesium does conduct electricity, so we would put a C for being a conductor. And then zinc also does conduct electricity. We would put a C there for being a conductor. So the next test that the students are going to do is a malleability test. So they're going to take a hammer and smash the sample, and if it bends or if it dents, that is going to mean that it has malleability. If it shatters into a whole bunch of pieces, that is going to mean that it is brittle. So we're going to put an M or a V for these. So malleable or brittle test, we would say that copper is malleable. We would say that aluminum is also malleable. We would say that carbon is actually brittle. It shatters into a million pieces. Silicone is also very brittle. Sulfur also very brittle. Magnesium is malleable. You can actually bend that with your hands, as well as zinc is very malleable. You can hammer that into a sheet as well. So the next test that we're going to do are chemical reactions with the metal. We're going to react them with acid, and we're going to react them with a blue solution of copper sulfate. So what you would see inside of the well plate to start with is this. So in the empty well plates, you can see that this top left one, this is going to be our sample of zinc. This is our sample of carbon. This is our sample of silicon. This is our sample of sulfur. This is our sample of aluminum. And well number 6 is your sample of copper. And then the last well is the sample of magnesium. So what you would see when you react these with acid, and when you react them with copper sulfate, is either with the acid, you will see productions of bubbles or a gas being produced, and with the copper sulfate, you're going to actually see whether they had a color change or not. So if we look at the results here, we can clearly see that the first one, our zinc, produced bubbles, so that is a yes. We would say that carbon and silicon and sulfur did not produce bubbles, so we would say those are a no. Our sample of aluminum is a yes. Our sample of copper is actually a no, and our sample of magnesium is a yes. So one of these is actually what we call a noble metal, and it is very highly resistant to corrosion, and it would theoretically give us a positive test, but because of this particular metal having a high resistance to corrosion, it gave us a no. So what we're going to do is go ahead and fill in our results there. So we would say that copper actually did not react. We would expect it to, but it did not. Aluminum was a yes. Carbon was a no. Silicon was a no. Sulfur was also a no. Magnesium, yes. And zinc, yes. The next one we're going to look at is the reaction with copper sulfate. So if we look at this, it is a little bit hard to tell here because there is a blue solution, but I'll kind of walk you through these. The first one, which is our zinc, is a definite yes. It turns sort of a brownish, darkish brown color. The next two or three samples of carbon, silicon, and sulfur, those are going to be no's. There's no reaction there, no color change. You can't quite see it very well, but the aluminum was going to be a yes. The copper is actually a no. If I pulled out here of the solution, you would see that it actually does not change color, and being that it's very highly resistant to corrosion. And then the last one, magnesium, was a definite yes. You can see all sorts of new substances formed and the definite color change. So we'll go ahead and fill those in our data table. So the reaction with copper sulfate with copper was also a no. With aluminum, it was a yes. Carbon, so no. And with silicon, also a no. Sulfur was a no. Magnesium was a definite yes. And zinc was also a definite yes. So we'll go back here and make sure that you have filled in your luster or no luster. Make sure you filled in your predictions. And then now based on this, you're going to fill in what is the actual results telling us that these things really are. And just remember that one of them is what we call a noble metal that gave you results that were not quite as expected. So once you finish filling out your data table, you're going to go ahead and answer these questions. Most of these questions can be answered using the background information here at the top or your data that you got from the lab. So go ahead and fill this in. Up at the top right, you're going to see where mine says save. It's going to say turn in. You're going to turn that into me, and then be prepared for tomorrow. We're having a follow-up assessment on Schoology to make sure that you understood the